Thank you very much for this opportunity to speak here about our conclusions and this study about the analysis of the thrombus composition after each pass. So I'm Rita Dominguez and I'm a biomedical engineer. I work full-time for Cerenovus, the neurovascular division of Johnson & Johnson. And in Cerenovus, I belong to the NTI team that probably some of you have already heard, or because we have been in this meeting for a while. And the NTI team stands for Neuravi Thromboembolic Initiative. And it's basically a team within Cerenovus that is dedicated to understand everything that relates to stroke. And by that, I mean understand the core problems that are challenging right now, this field, then try to do our own research in order to be able to replicate the problem and these problems in a lab environment, and then do our own investigation in depth through our internal testing, internal research, or through collaborations that could help us understanding better this field and be able to provide new insights, new methodologies, and bring important and useful inputs, for instance, for the development of techniques and of solutions, as it was the case of EmboTrap, our stent retriever device. So the most part of the work that I will show here is produced by this team, the NTI team that is all over Europe, but mostly in Galway, Ireland, where is our neurotechnology center. And what is our motivation? Because we see that the recent studies show an improvement in the recanalization success. But there are still, in the recent studies, there are still 20% of cases that the recanalization fails, so no success is achieved. So we believe there is still a significant room for outcome improvement, and that's why it's so important to understand the problem, to try to come up with new solutions. So we really want to study the problem properly. In that line, I will show you 4 videos, in vitro videos, in this first of different types of clots with different techniques. So in this first video, in these first 2 videos, I will show you 2 different types of clots. In this one, 40% red blood cells rich clot, so a red blood cells rich clot, being retrieved with a normal stent retriever. And in this first one, we see, it's a typical red blood cells rich clot, so easy to dislodge, so nothing really important to note here. But the story is completely different when we are talking about a fibrin-rich clot. So much more mature, and you see it does not move in relation to the vessel walls. It actually rolls inside the device, offering much more difficult to the engage and to the retrieval. Another important aspect that we notice in our in vitro studies is the clots that are heterogeneous. So this clot here, it has a fibrin-rich tail and a red blood cells rich tail and a fibrin head. And when retrieved with a generic stent retriever, what we see is that the first part, so the red blood cells rich part, is engaged, but the fibrin part remains inside. And also it's challenging when doing it with an aspiration catheter, in which during the retrieval, actually there is a separation of the 2 parts. And what is nice to see here is that different techniques, still a lot of challenges ahead. And also another thing that really interests us is this gap, because okay, there is an improvement, a recent improvement on recanalization success, but there is still a huge gap between recanalization success and good clinical outcomes, that at the end of the day, is the most important thing. And what more and more studies show is that it's not only if the recanalization is achieved or not, but how. So for instance, achieve a TK3, it's not the same as achieving a TK2B. Also, the timing when the recanalization is achieved plays an important role. So it's not the same thing achieve the recanalization in 1 pass or in 3 passes. Actually, lower the number of passes are associated with better clinical outcomes. This was also shown in our ARISE-2 study. This is our major clinical trial for testing the EmboTrap. And we saw that there was a significant increase in good clinical outcomes when the perfusion was achieved in one pass. So that should be the goal, TK3 in one pass. And that's why we keep doing this work of better and better understanding and keeping understanding the different factors that affect the mechanical thrombectomy. So, and these are the major ones. So the tortuous anatomy of the brain that always bring access problems and can increase the timing to achieve the organization, the timing to achieve the occlusion. Also the vessel disease that it was already discussed here today, the clot itself, as I already mentioned and showed, and of course the techniques that you have been talking a lot today. The main one, and we've been dedicated more and more time, was the clot. And the work of an NTI with clots, as a long story, it started with the beginning of Neuravi, that was a startup that was acquired by Johnson & Johnson, and it was in 2010. And the way we thought about this was, let's try to understand the entire journey of the clot. How does the clot form? Where does it form? What are the conditions there before embolization? How does it embolize? Why does it embolize? Where does it go? And what are the conditions at the occlusion? Then the retrieval, the different techniques that can be used. And at the end, if the recognition fails, try to understand why it failed. And if the clot came, try to analyze it and understand better the composition. And looking to the composition, so when we analyze the microstructure, we can see evident differences. We can see some white portions, red portions. We can see them more intact or fragmented, more elongated or compact. And this sometimes, when analyzing a clot immediately after it comes out, it's really helpful to try to understand maybe why, oh, this is maybe a fibrin clot, so it's probably white, offer much more resistance. So these conclusions are easier to take and to see immediately. But when we examine the microstructure of the thrombus, then we are able to learn more about the features that result in their mechanical properties, that at the end of the day are a key point in the mechanical thrombectomy, and how the clot interacts with the devices, how it interacts with the vessels. And when we try to look to this composition, we looked in literature some papers, and these 3 papers were really good analyzing the histopathological composition of retrieved clots. And we combined the data of these 3 papers, and together we get this graph here, in which we see how diverse clots can be. We can have clots that are almost 100% of red blood cells, or clots that are mainly fibrin. And these studies from the literature were really and extremely important to develop our own clot analogs, the NTI clot analogs, using sheep blood, not human blood. And as I said, because for us it would be important to replicate these problems in a lab environment to help making these investigations in depth. But the main problem of these studies is that all of the clots were combined for analysis without differentiation between the pass number that was removed in. So it was an analysis per patient and not per pass. So that's why we performed this study to examine the clot and the fragments removed during each pass, after each pass of a thrombectomy procedure, and try to see if there is any conclusion that can be taken from there. So this study was realized, it took place in Beaumont Hospital, in partnership with Beaumont Hospital in Ireland. And what it was done was the fragments were collected after each pass, and each pass had their own fragments in a different container. So we would have as many containers as the number of passes. Then everything was documented and registered, and then they were sent for analysis. And the histopathological composition is possible to do due to histology stains, namely the Marshall scarlet blue. As you can see an example here of one of the fragments that was collected, in which red blood cells is in yellow and fibrin in pink. So you can have an overall idea of this study. There were 60 patients, 60 cases that were included, and we noticed that at the end, in about 30% of the cases, more than 2 passes were needed. So overall, it were done 138 procedural passes, and the technique used was up to the physician. We had no interference on that, but at the end, the information that we collected, 10% of the cases, it was used aspiration only, and in the rest, it was a combination of stent retriever and co-aspiration. So this is one of the cases. So here you can see that everything was documented. So where was the occlusion, which kind of technique was used, also if it was administered or not, RTPA, and the suspected etiology. And these are some of the images and graphically how we can see it. So we can see the fragments that come from each pass, and also the Tiki score after each pass and from which location the fragments were collected. And here, for instance, we see that pass 5, there was no clots. And we can see that the last passes, we see that it was necessary to get it to distal occlusions. There was distal embolizations, and they are mainly fibrin-rich clots. So this is another way to see it. Again, pass 5, no clot. And for instance, we can see now with the sizes, so we can have the relative size, the relative proportions. We can see that, for instance, in pass 6, the proportion, the composition of fibrin was much higher compared with red blood cells. And if we see, for instance, pass 1, it was pretty much 1-to-1. So this analysis was done for all passes. You can see there the case 4 that I just showed highlighted, but it was done for all passes. Here the results are normalized, but also we have it in this way in which we can see the relative sizes of the fragments collected. For instance, if we look to this case here, we see that the fragment collected in first pass was much smaller compared with this one collecting third pass, and also the cases in which no fragment was collected at all. Again, we noticed that as I said in the beginning, that in more than 30% of the cases, more than 2 passes were needed. And when we looked at when analyzing the composition by pass, we see that, so in the first 2 passes, the clots that were retrieved, in the cases that were retrieved in the first 2 passes, we see that the proportion of red blood cells and fibrin is pretty much 1-to-1. But that those clots that are retrieved in 3 or more passes, they tend to be much more fibrin rich compared to the first one. So we see that now the proportions is 1-to-2. So this actually validates, and the in vitro models that I showed you in the beginning, in vitro simulations in which we saw that the fibrin-rich clots offered more resistance to the engagement. Also that those videos of the heterogeneous clots, and we see that actually, yeah, so the red blood cells, rich clots, they come first, and this in a clinical environment also is aligned with that. And I think this information can be really useful, for instance, to develop maybe new devices that are more intended to 3 passes, to use in a third pass, more dedicated to fibrin, because we see that after 3 passes, basically we can assume that the content that is inside is fibrin-rich clot, or also to adapt the technique. And once when the imaging probably will allow to anticipate and to predict which kind of clot is inside, better adjust the technique in order to, as I said in the beginning, TK3 first pass should be the goal. And that's pretty much it. Thank you very much for your time. And I'm here to listen any comment, any question that you have.
Do you think that the TPA has any modifies the composition?
Yeah, we have been doing some preliminary testing on that, and now we are conducting a beta test inside. So with the silicon models, in which we expose the clot to a certain concentration of TPA and see the results. So, and then try to remove and see if there is any difference. We don't have the results yet, but we believe that, yeah, it has an impact. If it's for good or for bad, I am not sure.
Because some people argue that sometimes maybe it's better not give TPA because makes the clot looser.
Mhm.
So when you're doing thrombectomy, it might break and you have distal embolization. That's why.
Yeah, that's a very good point, because I have heard that I don't do procedures, so I cannot talk by experience, but I heard from some physicians that actually they believe that it could be better to do the opposite, because now the standard is TPA and then mechanical thrombectomy. Maybe do the opposite, like first mechanical thrombectomy, and then if there is some dense distal emboli that is still inside, administrate some RTPA that could help getting away of these last pieces. But yet we don't have a correct or a definitive answer for that. But we are actually looking for this aspect now. Yeah. No? Thank you very much.